Good morning everyone. Today I will be presenting about the principles of parallel algorithm designs. So in this PPT we would be discussing about the fundamental principles of the efficient parallel algorithms. Okay. In this PPT we will understand what is parallelism, the key matrix, the challenges and the optimization strategies. Okay, so starting with the parallelism. So parallel computing involves executing multiple computations simultaneously. This is not about the speed. So in this basically we are dividing the task into smaller subtasks so that the all the subtasks should be processed together to make the bigger task to be finished early. Okay, so the distributing the workload, basically it means that the same operation is applied simultaneously to the different parts of the large data sets. If you are taking a data set and then we are using parallelism, so it's dividing in the data set into small parts and then parallelly working on each of them with the same operation, we can say. So mainly the challenges are that the data distribution and the efficient handling of the data dependency. So the load balancing is very critical. Okay, so the task parallelism, unlike the data parallelism, task parallelism focus on the distributing different independent computational tasks among the processors. So the each processor executes a distinct set of instruction, often on a distinct data set. Okay, so we can take an example of the if we are assembling in different lines. So different tasks can be performed on different lines, and different tasks, let the persons in the line which are being assembled taken as a task. So different tasks have been assigned to different lines and different operation can occur on each line. So the main principles of parallel algorithms are: first, the speed. Okay, so the ratio of the sequential execution time to the parallel execution time, ideally linear with the numbers of processors. And the efficiency and the scalability, how much the algorithm is scalable to a large extent. Okay, the challenges come with the first, the communication overhead. Time spent with the data between the processor can negate parallel speed up. Okay, so the assigning of the task or dividing of the task can take a lot much time. Second, load imbalancement. Uneven distribution of the task or the data can occur, which can increase the speed, decrease the speed of the completion. First, third, debugging. So the non-deterministic behavior and the race condition make identify and fixing error extremely challenging in parallel systems. And last, synchronization. The coordination between the parallel tasks can introduce delays and complexity. Okay, so the optimization strategies comes with the reduce of communication, dynamic load balancing. Like we discussed in the last PPT, is that the communication can increase the time of the completion, and the load balancing can give some of the processor more task or distribute the data unevenly. And then we have overlap computation and communication and fine gain turning. Okay, so looking forward to the emerging trends, the landscape of HPC is continuously evolving. Modern architecture, particularly those incorporating GPUs and specialized accelerators, demand a new approach of parallel algorithm designs. So, like as we know that AI and new upcoming GPUs have improved so much that they can work very good with the parallelism. So we can like create new parallelism algorithms and work on them. So the key takeaways are like master the principles. Like the principles are very easy. Okay, so first is speed, then efficiency, and the distribution. And we have to also focus on the scalability, and most important, the hand-on practice. If we are understanding something, so we have to also have practice of it. So I would recommend that the upcoming GPUs like CUDA and OpenMP, people should work on it and should understand how the things are working. Thank you.